Let's see. Yes.
Thanks a lot, Antonio, and thanks everyone to join from all over Japan, and I guess some of you from the US. This is joint work with a former PhD student, Jan Trenczek, based on two chapters of his dissertation, which are now two papers, as you may have seen. I have presented each paper in about 20 minutes, and there's huge overlap. It depends a bit on your questions and comments how long we want to go. Our starting point is something you, I guess, have seen, which is the immense discrepancies in output per worker across countries. So a worker in a country like Burundi produces only 1/70th or 1/80th of a worker in the United States, and that's already correcting for purchasing power parities, right? The sample we'll be using is a bit slightly smaller, so I don't know if you can see my cursor or not, but we'll have, thanks, Sven. We'll have down to basically India, Vietnam, up to the United States or Luxembourg, depending always on the sector, etc. But this is still a difference of about 1 to 7 in terms of the per capita output dimensions. And if we plot that as a density distribution, it would look something like this. No? And the paper I'm going to present to you are the papers. There are empirical papers with data, but I think to my knowledge, you're mostly working on theoretical aspects. But I think they lead to very interesting insights. Particularly, I guess we want to have a world or a concept of development where we allow for the idea of convergence, right? But where the world income distribution is relatively stable over time. No, I mean, Antonio has presented in Rome also these papers on convergence, right? I mean, depending on the decade you look at, you may find convergence or not, but even though it's significant statistically, economically it's very small, right? So the income distribution of the world is relatively stable over time, but it's increasing. So the question we want to ask is, if this is the actual distribution of output per worker across countries, then by how many percent would this distribution that I've just shown you, ranging from Venezuela and Burundi up to Luxembourg and United States and Norway, how much would that distribution narrow if all countries in the world had access to the best production technology? And I have quickly looked, but making a poll in Zoom is a bit trickier than I had thought, right? But I guess like all of you have some thoughts about that, and I guess the standard answer we would give is probably around 50%. And the surprising finding I will give you is that it would not narrow at all, and you'll understand, hopefully, in 15 minutes why.
Can I
Yeah,
ask
sure.
a question observation? It's interesting that how important is the fact that things are plotted in logs? Because I was thinking that we are used to see distribution skewed left when we look at, say, personal distribution of income, and this is skewed right. So it looks like the problem is the fat left tail, not, as we usually think, the fat right tail. So countries are not like individuals.
Yeah, excellent point. Does it matter? I mean, I guess it goes back a bit to this whole convergence debate with club convergence, etc., right? Where what's his name made this point about you have this two peak distribution in the world, right? Sorry?
Danny Qua had that.
Exactly. Yeah. Sorry,
just skipped me now. We talked about that in Rome when Antonio presented his paper.
Yeah, exactly. Right. So, and that seems to have gotten more one-peaked. I guess that's some of the papers I will show you later on over time. Is that important? Do you have anything in mind why you're asking this, or is it just?
It just struck me as so the first thing I was wondering whether the skewness is coming from the log. I don't think so, but just worth checking. But
yeah, because even for the personal income distribution, we would Well, we would see that. So usually, I have a paper with household and poverty data where we use a log normal approximation, right? So in logs, it's relatively normally distributed on the country level, no?
Mhm.
Here, I guess it has to do a bit also with, right? I mean, these countries like Burundi and Venezuela currently, I mean, I guess it also has to do with the purchasing power parities, right? It's very hard to measure prices in Venezuela.
But how, I guess, on the same point, so the countries are weighted according to their GDP.
No, it's
So
unweighted. It's an unweighted distribution. Yeah. You could do that if you consider a country as a unit, then you do it as I do. I guess that's what most people do. You could say large countries are more important, then I would weight it by population. Yeah, you could do that in principle. Yeah.
I guess one way to think about it is that in all the literature on inequality, when we think about personal distribution of income, the obsession is the right tail, the top
Yeah.
percent.
Yeah.
When we look at countries, the problem seems to be a problem of the bottom.
Yeah.
Bottom countries are not catching up.
Yeah. I find it super interesting. It's not like tightly related to, or not. It doesn't depend on what I present to you. But let's get back to that point because I think the way we think about technology may help to link back to the distributional aspect. Okay. So thanks for flagging those points. I find them super, as an empirical researcher especially, I find them super interesting in the whole debate also around the Qua's work. And also the question, what drove this more one peak distribution over the last decades? I think that's very interesting, but not something we directly speak to. No? So the more interesting part is that the distribution would not narrow in the framework I'm presenting to you today if we give all countries access to the best production technology. And the question we have to fix in our minds for that is, what do we mean with production technology? So the standard approach that people would take is to say, I have a production function, and usually that would be a Cobb-Douglas for many empirical applications in this literature that I'll discuss later. The small letters indicate per worker units, and you see this capital output share alpha. I think nothing that every one of us has seen yet. And then the idea would be to back out this total factor productivity, which I refer to here as technology. I think production technology more broadly refers to the idea of how to bundle together products, not products, but factors of production. So this is what people would do. And then how we think about aggregate differences in output per worker is then in the standard macro framework to say, well, they could stem from differences in factor endowments. So we know that poor countries are relatively capital scarce, and they could come from differences in factor production, right? So the question I just posted out to you by how much would the distribution narrow is to ask, well, how much of the differences we observe come from this right-hand side? And then you could drill down, well, the individual production factors, and you could then on the right-hand side, this is the second paper we have, is on well, differences in factor productivity. You could see them as productivity within sectors or within firms. And then also like how are resources in your economy distributed between firms or between sectors? So are you ending up, so this is an allocative efficiency question. Are you ending up with the most important resources being distributed to the most productive sectors of firms? No?
Can I offer an observation at this stage? I think that from an empirical viewpoint, it would be grand to add on the left-hand side, in factor endowments, also natural capital.
Yeah.
And this connects to what we were saying earlier.
Yeah. No,
A lot of the countries in the left tail of that distribution are going to be commodity exporters, and I wonder whether the data that you guys have available at Groningen would allow to I mean, theoretically, it's easy to add another input, call it natural. The other thing is that natural capital is not really necessarily produced within the system. And here you have physical and human capital that we tend to think as endogenous factors.
Yeah.
Something to think about.
Yeah. I mean, capital that directly goes into production will be somewhere and up to some extent in physical capital. Huh? So a cow that produces milk is a capital good. No? A calf
Yeah.
that does not yet produce milk is an intermediate input. So it's accounted for, but I agree, this is a super interesting question, and it's something I'm working on also. Yeah, Francesco Caselli has worked a bit on that in his
Right.
framework. But yeah, it's important, and it's getting more and more important. You also see important papers published on that. We don't do it here. I have a running project on doing exactly that because I fully agree it's important. Yeah. So, and the standard answer in this framework would be, well, roughly depending a bit on which countries you look at and how you measure the inputs, you have about 50% come from factor endowments, usually in this Cobb-Douglas framework, 50% come from TFP, and then within that box, you have about 50% coming from allocative efficiency differences. So meaning that misallocation usually accounts for about 25% of aggregate income per worker differences. That would be the second paper. Let's see how much time we have and how much time you want to spend. I'm going to focus on the paper which since yesterday is officially accepted for the Oxford Bulletin. Even though it's more advanced already, I think it's the paper that has for you all a much more interesting insight, at least for me personally. I could say that I found this most interesting. So I'm going to focus on this aspect in the first part of my talk. And I just want to mention, so there's also human capital here. So one thing that's running in the background is the human capital aggregate. I'll quickly say what's going on there, but I decided to keep that out of the discussion because the insights there are a bit narrower and makes things more complicated. So back to the production structure, we have defined technology. We know that TFP is a measure of our ignorance and captures many, many things. But then what we would do in standard development accounting is to say, well, now we can calculate this. So usually we have data for output, we have data for capital, we have data for human capital, which is coming from educational measures that are aggregated up. And then either we impose alpha by a labor share measure, or we just say something like alpha is 0.4 because that makes quite some sense. And so that means we can then back out the technology level. And then what we're doing in development accounting to answer the question I was posing by how much would the distribution narrow is to say, well, let's take every country's capital and human capital endowment and let's create, and this is an important point to understand so that you understand what we're doing later on. And then let's give each country the best production technology that's out there. I can give them, and that's the interesting thing in the Cobb-Douglas, I can, of course, give all countries, I can just say this is one for all of them. It doesn't matter what I'm giving them. If I'm giving them the best, they would end up probably with a production technology like Luxembourg, or if I would include it, it's probably Ireland or something. That doesn't matter. The key point here is that in the Cobb-Douglas, all countries would pick the same A, the same best A. It's the same for all countries. That's the crucial point. And I'm giving all countries the same production technology. And so in this hypothetical work, countries only vary in their factor endowments. And therefore I can say, well, if I look at the variation in this hypothetical measure and look how much it varies, and I compare that to the actual variation in income per or output per capita or per worker that I just showed you, right? Then I'm measuring, this will be our key measure later on, so that's why I want to spend some time here. Then I'm saying how much of the variation in output per worker in the world is explained by factor endowments. And usually that's about 50% here in the Penn World Table data that I've shown you is actually even less. So meaning that almost 2/3 in the data I've shown you could be explained by technology differences across countries. So that means if I give all the countries with the Cobb-Douglas the same production technology, then I would narrow the income distribution by 2/3. I'll show that to you, I guess, in the next slide, what's going on, because that's also insightful. You see, again, in blue, the same distribution, left tail, as Pietro has pointed out, that I've plotted beforehand. And then I'm giving each country the best observed production technology that I can calculate from the Cobb-Douglas. And you see two things I think are worth pointing out for later on to understand the conceptual differences. First of all, the richest countries will not change much because since every country will pick the same production technology, the richest countries won't benefit. The richest countries stay the same. But of course, you see a strong convergence from this hypothetical counterfactual exercise, because now the poorer countries, which we think have lower production technology or lower efficiency, now will catch up. So the distribution narrows a lot. So this is what's going on in the standard framework. Nothing new or striking here. Goes back to basically Solow's idea to model production structures in the 50s. Sier and Klenau have published essentially with that in the AHA macro. Of course, people don't publish those things, right? Because they're quite boring. But I've been working at the World Bank, or if you work at the OECD or something, you would do that all of the time. You would be the country economist for Ethiopia. You would ask, okay, why is my country poor, right? Then you would do some development accounting exercise and see that, Ethiopia lacks TFP compared to other countries. So people do that. Of course, this is not what's happening at the research frontier. In research, I guess we see Cobb-Douglas, that's a strong assumption. In many papers, we're not willing to make that. And a lot of Darnashemoglu's work on directed or biased technological change. You see empirical evidence from various levels that Cobb-Douglas has to be rejected. There's a lot of work on market power, returns to scale, etc. Right? So from that perspective, it's why is in this literature Cobb-Douglas still so dominant, or the basic assumption? And that, I guess, has to do with the fact that, you can accept the Cobb-Douglas, or you can say, well, Cobb-Douglas is stupid, but there's two ways to consider the Cobb-Douglas stupid, either because you yourself a bit are not the smartest and you haven't thought through in full detail what it implies to give up the Cobb-Douglas. And you'll see later on that things get quite complicated, or you have a solution for that. And I think during Jan's dissertation, we moved more from this very naive interpretation of, oh, Cobb-Douglas doesn't make sense. Then we had to learn the hard way. Well, it's tricky to do things otherwise. And I hope we're now more on the right-hand side of this picture.
Yeah, Konstantin.
Yeah.
Yeah, can you explain a bit about how that data on human capital is obtained? So how do they calculate the human capital across countries?
Yes, that's an interesting question. I'm going to the data quite late, but what is usually done, so in the Penn-Wall tables, or let's go back to the production function, right? So you see that if you would write that down not in per capita terms, but with the labor, you would multiply the H, the small capital H, with the L. That would say, well, there are many laborers. A typical unskilled laborer would get a weight of 0, of 1. So the H would be 1 for unskilled labor. That would be the minimum education. And then you have, basically Robert Inkler is doing that at our department, or his team. Then you're getting education data from each country. And you, from Mincer regressions, if that means something to you, that's a micro technique where you estimate the returns to an additional year of education, which is usually done by primary, right? As Esther Duflo and co-authors say, well, the returns to education are quite uniform across the whole board. which leads to very interesting differences then in terms of poverty traps or stuff. But they do it by type of education. They assume there's a return to education, competitive markets, and from that you can weight upwards you compare essentially the high skilled laborer who has 12 years of education is then a value above 1. No, I don't know the value, but 1.5, say, compared to the unskilled. So the unskilled is the baseline with a 1, and I don't know what is the highest value of age in the data, probably something like 2.
So I'm just wondering because in the equation 3, so K is per capita amount of capital, so which is going to increase over time. If there's a kind of balanced growth path, it's going to increase at a constant rate. Then if you want to have a balanced growth, then you also want to have H to grow at a constant rate. But if H is calculated, as you said, in terms like years of education, there is obviously kind of a upper bound, so it won't be increased at a constant rate in the long run. So I'm just wondering how H can be consistent with balanced growth or long-term growth.
Yeah. I don't have an answer to that. I'm also not a theory person. I guess it refers here. I'm doing cross country at a point in time. No? But I guess where you're going into, maybe the formulation I'll give you later will be more interesting from that perspective. But this is how we're doing it in practice. I guess it relates a bit to, so Dietz Vollrath has this book about fully grown, right? Where he also says there's an upper limit, and then especially you have this fast growth in the boomer generation where people start going to college at like tremendous rates, etc., right? And that adds a lot to growth. But there is a sort of upper bound here on the age, sure.
So it's mostly concerned about the cross-sectional analysis, not about the time season.
I won't focus on the time dimension. I'll focus on cross sections and counterfactuals in that cross section.
Okay.
But the point you're bringing up is spot on. Also because what we're doing in the paper, this is the point that it doesn't address the theoretical point you're raising about balanced growth, right? But if you do what people are doing, like Robert Inkler, and what's very common, it's to say that the skilled worker or the educated worker is more productive than the uneducated worker. And if you're doing it that way, you can completely get rid of your unskilled workers, right? So you're assuming perfect substitutability between worker types, which is also a strong assumption. I'll quickly show you in a slide later on to what literature that relates, because we're also tackling this. So we said Cobb-Douglas, not easy to publish because boring anyway. So what people did in the around 2000, gave you some papers there, is to say, well, then let's estimate the production frontier that is non-parametric, right? So they said, well, Cobb-Douglas makes so many assumptions. Let's get rid of the idea of a parametric production method altogether, or production function, and estimate that non-parametrically, which highlighted that more of the differences in income per worker or output per worker are explained by capital endowments. This literature, especially the first paper by Kumar and Roussel, also kind of addresses what we discussed earlier, this idea of the twin peaks versus one peaks distribution. So if you're like interested in that, but it's a purely empirical paper. So from a theory perspective, I'm not sure you could see this more as a styled facts paper then. And that's also the problem of this literature, right? It gets rid of the idea of a parametric production frontier or function altogether, right? And most of you are working with theory, so you want to have a parameter to work with, and you want to have some structure to work with, and ask especially the questions that Rio was pointing out. Okay, where does growth go in the long run, etc. No? So the obvious alternative here is the CES, right? Because it gives way more flexibility and is still a bit like new. I mean, it's still sometimes tricky to understand what's going on, but you can trace it back a bit better and play around with it, get more structure on it. So the first one paper that kind of played around with that is actually Francesco's handbook chapter. And there's a paper in Journal of Macro that basically said they looked at the CES and said, look, with CES, all of that changes, but they just play around with the CES parameters and they don't have an empirical estimate, right? So we want to really pin down in our paper what exactly are the parameters that we should use, which are the most realistic ones. And we're drawing here on this literature on econometric estimation of CES parameters. And for reasons that will become clearer later on, we're doing that at the sector level because later on we want to do the misallocation thing. There's also a recent literature on doing that at the sector level. And then there's exactly this literature that I was just referring to is about, well, how do we aggregate human capital in this, right? I mean, do we assume that that high skilled and low skilled or highly educated and lowly educated workers are perfect substitutes and I can get rid of the low skilled workers altogether, which is the standard, I guess? Or do you want to make an assumption that to some extent they're complements, right? There's many papers on that. Francesco has contributed to that debate. There's a recent paper by Mark Bills et al. In the AHA Macro saying they're saying they're not perfect substitutes. They're saying the lower bound of the elasticity of substitution is about 4. So this will be also something we find and work with. That's running in the background. And you may see some results there, but as I said, the insights are not like super important. So moving to other things, and here you already see you can have some progress in the human capital side that is unbounded. We now have the CS production function with which I guess all of you have also seen, and here we are allowing also for the idea that you have factor-specific technologies. I've highlighted them to you in blue. So this is the idea that technology is not Higgs neutral, that we have innovations that are capital augmenting. That would be the first term in blue, that make capital more productive. Or you have innovations that make labor more productive or human capital more productive would be the second H term. You have your substitution elasticity. If the sigma is equal to, right? I mean, if you could estimate this sigma parameter or the rho and then infer your sigma, if you would end up with a sigma that is equal 1, then you would say, yeah, we can stay in the Cobb-Douglas world, right? Because even though for a non-math guy like me, that's a bit tricky to see, but you can show that this production technology becomes Cobb-Douglas if the sigma is approaching 1. And sigma smaller 1 means that the production factors, human capital and physical capital, are gross complements. The most extreme case, the Leontief, now with sigma approaching 0, where things are perfect complements. And if sigma would be larger than 1, which is not interesting empirically, as you will later see, then they're gross substitutes. You also see that things get a bit complicated. Also, maybe going back to Pietro's point, if you write down also here natural capital, you have to think through very carefully about the nesting structure, right? So you have to create nests of CS. That's doable, and people do that in the literature. But you have to fight hard with the referees also why you picked particularly this nesting structure and not another one. All right. What else should we say here? So Leo.
Yes, sorry about
No, absolutely.
Yeah. So I think that it's actually looks like very much similar to what I've done with Gregory Casey last year. So maybe you have heard about Uzawa theorem, which says that balanced growth can't be obtained if there is capital augmenting technical change. So
I guess that what your previous comment also referred to, that in the end, balance growth needs to boil down to a production function where where the age term increases over time, right? I guess that's the idea of this theory, no? No?
Right. But actually, in our paper in last year, which is published in JP Macro, which says that if you include natural capital, as Pietro said, which is actually, so it's multiplied with AKK term. So as you said, the nesting structure is very important. So you first nest capital with natural capital, and then combine it with a CS style with labor, effective labor like AH. So then you could get balanced growth. It's depending on the how technology moves over time. So maybe you can look at that paper. So because I know that this is concerned with cross-sectional differences, but you also want to be the theory to be consistent with a long-term change like balanced growth. So yeah, so just sorry about our paper. But
Yeah, no, that's super interesting.
That's
So if I
that's
understand
something you might be
correctly,
interested.
if I understand you correctly, you're nesting together the capitals, no? I
Mhm,
don't know
yes.
the paper. I'll have a look. You're nesting together the capitals, and then you're saying because you have nature in there, you have a bound on this term, right? Is that the idea?
Mhm. Yeah, I think so. Yeah.
Yeah, that's super interesting. Yeah, I'll look at
Yeah,
it.
so if you have capital augmenting term, and then AK times K will be increasing faster than output because K is increasing with the speed of output. And
Yeah,
then in addition to that, if you have AK,
yeah,
then if that increase, then this term itself increase faster than output, so which will break the balance growth
yeah,
situation. But if you combine with that with natural capital, the natural capital is usually growing slower because this is not you can reproduce natural capital.
yeah.
So you can combine with faster input and then slower input, then you could have the balance growth. So that's the idea.
That's super interesting. I'm aware of this theory debate. To be honest, I don't. I know that it's important to theorists. The full implication is not clear to me, but I know that it's
Okay.
out there. But
But
I
in,
also know that
in
people
the end,
work
then
with
yeah.
this production
Yeah.
function in the short run or something. Yeah. I mean,
Mhm.
the other way to approach this is the paper, I guess, by Miguel and Sato in the Restart 2 years ago,
Mhm.
5 years ago, where
Mhm.
they basically say, yeah, you can have the Cobb-Douglas with technology bias in the short run.
Okay, Leon Lissman and such. Yes.
Yeah,
That's another
exactly. Yeah,
paper. Yes.
I guess
That's
that's the
also
other way
yeah,
out
related to our
that
paper.
I'm
Yeah.
aware of this problem.
Yeah.
Huh?
Yeah.
That
Yes.
this is a
Yes.
short run production function that
Yeah.
in the very long run you have this adjustment costs. I think that's the idea in the theory, but as I said,
Yeah. So
theory
in
is
the long
not really
run,
strong.
their models converge to
And
Cobb-Douglas.
then you converge into the Cobb-Douglas case in the long run.
Yeah. Right.
This is super interesting. Let me put a spin that goes in favor that would make this even more useful for an empirical perspective. There is a sort of the risk that people start thinking that we do development accounting purely cross-sectional, and that lives in a different universe than doing time series stuff, the balance growth path that Rio is bringing up. One way to think about this is that keeping in mind the properties that need to hold in order to have a balanced growth path are an external sanity check on whatever you do on the pure cross-sectional stuff and vice versa. So in a way, paying attention to the things that Rio is bringing up adds discipline to cross-sectional exercises because there might be several cross-sectional specifications that quote unquote agree with the data. But maybe only one of them makes sense when you think about the balanced growth path. It's a way to think about cross-fertilization between these two ways to think about the problem. I mean, as a theorist, ideally, we would write down dynamic models with both the cross-section and the time series dimension, and we would do, I don't know, dynamic panels, something like that. But when you do development accounting, thinking about the property of balanced growth path can be an external check.
Yeah. No, I agree. I guess like I'm very much of the favor of the point you're making. I guess what many of my colleagues a bit like don't see is the value added from this cross check, no? Because for them it's just purely theory, and why would I care, right? I mean, why is this just something that's a nice property, or in an equilibrium, or why do I have to bother, right? I think this is a bit the disconnect. The other one is from a policy perspective, right? I mean, it's not like policy relevant, or that policy focus a lot on sanity cross checks those days, right? So people in policy would do all sorts of crazy things, even though they're not doable in the long run, right?
Well, I understand that people behave their way in the way they do their own research, but that doesn't make it right.
No, absolutely. No, I agree. I'm
I
just
believe that
trying
the concept of
to,
balanced
no,
growth is
yeah.
not purely theoretical. It's very relevant empirically.
Yeah, no, I guess I don't see this fully, but I see where you're coming from, and I think we should think a bit along those lines, because I'm bringing up those points to say, what if we want to make that point stronger, what resistance will we face? I guess that's why I'm pointing this out. No, but I think it will be super important. No, yeah. So yeah, no, let me just, in terms of the definitions. So we have those two technology terms basically that are not factor neutral now in the CES case, and we refer to pairs of these technologies, no? Or a pair of those terms as the production technology. And each country or each country sector has its own production technology. I guess that will become clearer later on why that's important. And it's not like so these two terms are bundled together. So you cannot, the idea is of the exercise we're doing is you cannot pick the AK from China and the AH from Luxembourg. That doesn't work, right? These two, they come together. They come in a bundle. No? Just a reminder to you, rich countries or countries that produce high output per worker are countries that are relatively capital abundant. Now you see this very strong empirical correlation in the data. So let's think through a bit. If production inputs are complements, right, in the which is, you will see the empirically relevant case. So that means that physical and human capital are complements, and you're a capital-rich country like Italy. Italy, I think, is one of the capital-richest countries in the world. You have a lot of capital, huh? But a lot of capital doesn't help you that much because you have the complementarity in the production structure. So what you want to do is you want to find technologies that are labor augmenting or human capital augmenting. Does that make sense from the right? You have a lot of shovels. No, that's the typical Leontiev case is the shovel and the worker in the field. You have a lot of shovels in your country, but you have very few workers. Then maybe working with shovels is not the greatest idea. Maybe you want to invent some type of machine to work in your agricultural sector. And I guess that's what's happening in practice. And this is like that makes this work so, I don't know, interesting to me and my co-author. So we all the time we send each other pictures from when we go on vacation and see some people working somewhere, the way how they work. So this is, I have not taken this picture, unfortunately, myself. It's from the internet, but it's from Ethiopia, where I've spent some time also and worked on. And you will see this in low-income countries very often. You see, those are very capital poor countries, and they find partly very innovative ways of bundling together labor and capital. So they have one of these machines, and the machine is there. It's running every day, right? They have these one or two shovels. They make sure that the capital is used 24/7, more or less, because there's little of them and there's many workers. And if you have a production complementarity, then this is what you want to do. You see also in the background, you see how they build up the, how is it called? The structure for the building is like made with cheap wood, right? Probably human capital in this or labor in this country doesn't matter even that much, that you have to make sure that every worker survives in this production site. No? On the other hand, I mean, Italy is now very modernized and I feel like very quick in building structures. I was recently in Cologne and you see like at the university, a lot of construction sites and things going on, but nobody's working, right? So you see this, first of all, one worker commands way more capital in monetary terms in rich countries. And also, you know, if you come from a poor country and see like machines standing around, you would say these rich countries, they're very unproductive, right? Because if we would be in my country, in the poor country, we would make use of capital all the time. So I guess this is what, for me, makes also this production structure very, very interesting. So this is just to give you an intuition of what's going on. What does this mean in terms of data? So this is a picture of that plots on the vertical axis the human capital augmenting technology parameter versus on the horizontal axis the physical capital augmenting technology term. And each of the dots here is an actual production technology in our data set. You'll see later on how we derive them. Two observations. First of all, if you think the world is Cobb-Douglas, you're forcing your technology to be on the one line, huh? It's not a 54-degree line because the axes are a bit scaled differently. But Cobb-Douglas means you have to be on the depicted line, right? Because there's no factor bias in your technology. The other important thing to consider is suppose you're the example country. I really don't recall what country that is, but it's right from an actual country. And I said, let's give each country the best production technology that it can achieve. That's the hypothetical exercise, right? And we know in a Cobb-Douglas, we would always move, if we find a better production technology, we would always move out this straight line, no? And each country would end up with the same production technology in the counterfactual. Here, the example country, well, if the example country is a capital poor country, then it wants to pick a production technology that is very capital augmenting. So this country would then probably choose point C, which happens to be China, I recall that, point C as a production technology. Right? Because this is the technology that gives the country the highest boost for its scarce physical capital. If the country, on the other hand, would already have a lot of capital, you could have the interesting situation where you say, well, I already have a lot of physical capital, but with the production complementarity, this capital is not as productive. What I'm needing is more effective units of labor or of human capital. And this country would therefore be willing even to forgive some of its capital efficiency, if you want to, and move to production technology B, which makes most out of the scarce human capital that it has. Or it's relatively balanced, then it may move to point D. I think these are the 3 points. I think there's also 1 point here, which is a possible optimum, but I hope you get the point. Your factor endowments pin down which optimal technology you want to pick. And it's no longer the case that each country picks the best optimum technology. That's the framework that Francesco Caselli especially developed. 2 more observations. The technologies are very discrete. So that's also a difference to the Cobb-Douglas case where you move smoothly along the line if you want to. So here you can think of, all sorts of innovations that make jumps, right? Antonio presented, of course, in a very different setup, but this idea of small granular versus large innovations in Rome. Yeah, and there's no production technology frontier. Huh? So technology is only an option if the technology is there and used by another country. Huh? So you cannot choose a point that is not occupied, right? You could say there is a fictive frontier here, but those are no valid points. Huh? So you can only pick a technology that exists that another country is using. Huh? That's the way of I think about that. That's given the substitution elasticity. These are the options to bundle together capital and labor. So a completely different framework. So what we'll do in the counterfactual is that each country sector is allocated its output maximizing existing technology. We plug that to the production function. We derive a hypothetical output per worker level under this scenario. And then we can again do the same I showed you for the Cobb-Douglas case. We calculate the success ratio, like how much of the variation in output can be explained by factor endowments. So I hope that is relatively clear now.
Yeah, I'm just wondering, so how do you calculate AH and AK in the baseline case? So
yeah.
it's usually okay, you have the slide. Okay,
Yeah, no, it's very hard for me to how to tell the story, but I feel like now, since this is now your question, I think the order of the slides is correct. So you have a first order condition, and you have the data for output, you have the data for capital, you have your labor share data. So the labor share data is basically you have that in the production structure. So this is the labor share data that you need in the first order condition, sorry. So this is how you can back out the technology terms. That also goes back to Caselli, I think. I don't know if there's another paper than Francesco's handbook chapter, but this is what you can do. So everything then that the next question then would be, how do I get the rows, which define your substitution elasticity, and how do you get the alphas, the share parameters? So this is where the paper by Miguel Leon Ledesma and co-authors in the AER comes in. I don't know, we already a bit like we've spent a lot of time, unfortunately, that we could discuss some things. I don't want to go into the estimation parts unless you want to. I'm super happy to talk about that for 20 minutes. What you should in any case see that the CES is highly nonlinear. Even if you take logs, which I've done down there, you see it's still highly nonlinear. Here we're imposing, maybe that's the only interesting part for you also, we're imposing to discipline the function. We're using here an approximation that is Higgs neutral, or it's not Higgs neutral, it's here the constant would be sort of a Higgs neutral term. And then here, this term, in case you can see it, this would be so factor bias technology in the data is a time trend, no? And the same for human capital. Here, this is a time trend. And that still doesn't allow you to identify your parameters in this case. What you need, and that's the trick that Miguel and co-authors suggest, is you can write down a labor supply function, and from that get to the wage regression, which is shown as equation 12 here. And you would have the same parameters in this regression as in the production function. So you're not adding additional parameters you have to estimate. Of course, you're adding assumptions, huh? But you're adding a second equation, and that, statistically speaking, gives you some additional degrees of freedom, so that if you have the wage data, which we do have, help you to identify the substitution elasticity. So the things we're after here is, first of all, the A is unclear, then this technology term is unclear, and the factor, or what are they called? Yeah, the share parameters are unclear. So, and if you estimate it in this nonlinear system of equations, then you can identify the elasticity of substitution. That's the point that Leon Ledesma and co-authors made in their AER. Data, the wild, I'm having those guys in-house, and it's still the best. It's still the best data as macro people that we could get, except for maybe the CLEMS data, which is only for Europe. Because with the socioeconomic accounts, you would have all the wage and capital data. You would have the skill levels of people in each sector. So that's the data we're going to use, or we're using. We're aggregating that up to 5 market sectors. I'm going to focus on this aggregate market sector. What you then still need to do is that you need to find purchasing power parities that are sector specific. People don't do that usually in the literature, but they should do that.
Konstantin,
Yeah.
excuse me. About the previous empirical specification, does imposing slope homogeneity pose any issue to like the story that you're telling? I mean, should we care about the heterogeneity of the coefficients that you're estimating here?
So this is an important point. I don't exactly know where exactly. So first of all, let's if you look at the data, it's panel data. So we use the panel data to identify those things, no? And the panel is relatively short, and your question is now the slope homogeneity. That's an important question in the following sense. You need to, from the theory point of view, you need to impose homogeneity on the production structure to back out your technology. Even in the simple Cobb-Douglas case, right? If you assume that the alphas vary between countries, then it doesn't make sense to talk about productivity or TFP, right? Because TFP is an index number. You need to impose the same production technology for all countries. Otherwise you cannot compare the TFPs. They don't have meaningful levels anymore. So you need to. There are people that estimate this country-specific substitution elasticity. I think it doesn't make sense. I mean, I think it doesn't make sense from a theory point of view, right? Because it boils down to the question. Like, let me give you an example. You're making an innovation and you come up with the idea of having robots. Is robots something that's capital? It is. Is robots something that is a factor-specific technology? I think it is. And do robots change the way how you can substitute capital for labor? Maybe it does, but then you cannot separate those things anymore. I mean, not empirically and not conceptually, right? Because you need to fix something. It's an Archimedean philosophical point, if you want to. You have to, in my view, you have to say everyone has to use the same sigma, yeah? And then you can back out all the country-specific other parameters. That would be my answer to that.
Okay, thank you.
In terms of estimation, if that was your question, so we estimated by sector. So each sector has a different substitution elasticity. I think that's fair. To have it country specific, yeah, that's too demanding in this nonlinear setup. There are theory papers also with a varying substitution elasticity, so there is some work on that. But I think, especially in the cross-section comparison, you have to pin down the substitution elasticity to infer everything else.
Okay, thanks.
Thanks for the question, Antonio. 38 countries, 5 market sectors. And then if you ask, right, so I quoted you that's the Cobb-Douglas assumption. The Cobb-Douglas assumption is the world is this. And you see that for all the sectors we're using in this paper, you see that even with the, I think, 90% confidence intervals, they're very far away from the Cobb-Douglas. So yeah, empirically, we should probably work with the production structure we are proposing. So here you see that we do everything on the different scenarios. This is a scenario that higher skilled workers or more educated workers are perfect substitutes at fixed ratios or at specific ratios for the low skilled workers. You can play around with that. I'm going to skip that. It makes things just more complicated. What we assume here is the case where this substitution elasticity between skill types is 4. That's the lower bound that also, is suggested by Bills et al. In their AHA macro. So what do you see here? This is the main result. Even though the graph is not very nice, you will see probably a more appealing graph later on to understand what's going on. This is the Cobb-Douglas benchmark. It shows you exactly what I was telling you, the standard frame, right? The standard framework, which is a special case of our CES case, says about 50% are explained by differences in factor endowments. The other 50% are TFP. This is the standard case we benchmark to. The CS we're using explains about 100% of the variation in output per worker with capital endowments. Yeah? So it says, the other way of saying this is if you give every country access to their best production technology, if barriers to technology adoption are removed, the wealth income distribution would not narrow at all. It would stay exactly as variant as it currently is. In other words, a worker in the United States would produce 70 times the output as a worker in Burundi. This doesn't mean that in the counterfactual, and this is important to understand, that in the counterfactual, output per worker in the US wouldn't raise, or in the countries wouldn't raise. To see this, I'm plotting you here again the actual distribution of the of output per worker. You see now that this is way more log normal, right? But this is throwing out all the Burundi, Venezuela countries for which we have no data. And you see our counterfactual. Remember what I showed you in the Cobb-Douglas case. In the Cobb-Douglas case, you have this narrowing of the world income distribution or world outputs distribution, because the richest countries or most productive countries, they stick with the technology they already have. Here in this CES case, very productive countries can still find technologies that are increasing the productivity of their scarce factor. And therefore, there's a lot of opportunities for the rich countries to additionally boost their output per worker level. And therefore, at each point of the distribution, everyone more or less finds a way to become more productive. You see this, I think that's why the whole distribution shifts. No? And you see this more clearly, I think, in the right panel of this graph, where on the horizontal axis, you have the actual output per worker level. And on the horizontal axis, you see the hypothetical output per worker level, which assumes that each country picks its output maximizing technology. There's two things I want to mention. First of all, the countries that are at the technology frontier, if you want to, they cannot gain. China, which was the point I was showing you earlier, China cannot gain. China has the perfect production, is at the frontier that's possible given its factor endowments. Why is that? Because China in our sample, let's not forget, is 2007, is a very capital poor country. China in 2007 does not benefit from using the US technology. The US technology is very labor augmenting. China in 2007 is still a country that's in a Lewis economy with surplus labor. It doesn't make sense to adopt US technology. Luxembourg doesn't benefit, and Ireland doesn't benefit. Romania, it seems, doesn't. Romania benefits a bit, right? So these are the technology frontiers. And you see the second observation here is, if poor countries would be less productive or more inefficient, then poor countries should gain in the counterfactual way more than the rich countries, right? The rich countries would already be in the frontier, but you see that across the board of the income distribution, the counterfactual shifts up more or less to the same extent. So that's what's going on in the counterfactual. The differences are a bit more nuanced at the sector level. I give you just quick an indication why. So in the finance and business sector, if each country has access to the best production technology, the the counterfactual income levels would even increase in the CES, and that comes from the fact that you have those small countries like Luxembourg or Ireland that have these very weird production technologies, and it's a sector that's very capital intensive. Yeah? But you see some variation across sector. What you see throughout, however, is that I think except for one special case, that's the CES counterfactual always explains more through endowment differences than the Cobb-Douglas benchmark.
Can I make a comment on the previous slide, which I think is the important result? I think the two things you're bringing two things here that make a big difference. Number one, there is a concept of appropriate technology lurking in the background that is not part of the conversation in development accounting. If I think about the reference that you gave us before.
No, that's Caselli. That's very much actually in the forefront. I would say it's the appropriate technology thing that Francesco developed. He has a whole book on, I think, production technology across space and time.
Right.
Yeah,
So
that's exactly the framework we're using. Yeah.
right. But if you think about the other contributions, the definition of development accounting as they came up with in the 90s, abstracted from these things. Number two, and again, this must make a difference. If I think as an endogenous growth theorist, now you're saying that the countries choose their technology. And when you choose your technology, de facto your technology becomes an endogenous variable. And that endogenous variable says that technology becomes a function of factor endowments, because those are the deep determinants. So in a sense, it's not surprising that technology doesn't explain the variation, because basically that's what. But what is surprising, and this comes from this concept of appropriate technology, is that the allowing countries to choose in your counterfactual, what's happening is that you're not giving to. If I understood the counterfactual is when you're giving the best technology to a country, are you giving their best technology or some notion of best technology similar to the early development accounting studies where technology was in some sense common to everybody? There was only one A, and then you gave the highest A to everybody, because that must be the difference.
Exactly. I think you're spot on. So either you're very quick in your mind, or I tell a story in the way it should be told. Maybe it's a combination of both. No,
Wait,
exactly.
Are you going to tell us this later? Then I'll wait.
Sorry?
Are you going to tell us all of this later?
No, I think I already,
Then I'll
in a
wait.
sense, I
I
already
don't want to
told it
jump
to you,
behind.
but I also have it in the conclusion slides in a way. But
Okay.
no, just to your second point. No, exactly. You're giving each country its best technology that is best for the country, which is given their factor endowments, their output maximizing
But
technology.
that explains your counterfactual then, because when you give the country its best technology, that's a function of the endowment of the country.
Exactly. Yeah,
I
that's
have
what I
written
said.
endogenous growth model.
That's what I said for this
stuff.
example country. The optimal technology, whether it picks B or C, depends on its factor endowments. Exactly.
And in a sense, this tells us that the counterfactual that was at the heart of the early version of development accounting is in fact not almost meaningless, because once you introduce the idea the technology must be appropriate to the country, then that counterfactual, that exercise basically doesn't tell us anything.
That's what you said, but I would agree.
I'm old enough that I can be nasty to people who are not even in the room, so don't worry.
No. I mean, I would fully agree with what you're saying. I just need to defend it up to the point that I say that what we are doing is interesting, right? So because if I say upfront the whole idea of the development accounting doesn't make sense, then yeah, what's our contribution? But yeah, the way.
Careful. I'm not saying that development accounting doesn't make sense. I'm saying that because development accounting is essentially let's look at the cross section, forgetting the time dimension.
Yeah.
So there's nothing wrong with that in principle.
Yeah, no, I guess in a way it's not if you're imposing that, right? And then you have to impose, I mean, that relates to Antonio's question and my answer, you have to impose a common production structure, right? Then it's clear that poorer countries must be less productive from the TFP term. It's almost clear, no?
Oh, careful. In the empirics, what you're imposing is common parameters, not common A's.
We are imposing common parameters, yeah.
The A's are not imposed, and
The A's are not imposed, no?
exactly. And so that the parameters of the functions are common, I have no problem with that.
No,
So
it's needed.
from a word with a single A, and there is a notion in which the highest A given to the poorest country should do the thing that in old-fashioned development accounting they told it would do. It would lift all countries up to the top. So it would erase the variation across countries. Your point is that no, because now there is they choose their A, and the fact that your A is a bivariate variable rather than a single scalar variable, I don't think that's important, because if I think of A endogenous, even when there is a single A, that A is a function of the endowments of each country. So of course, factor endowments are going to explain everything once you make A an endogenous variable. The incarnation of development accounting is essentially growth accounting, but in levels instead of growth rates. And so A is a residual.
Yeah.
Here you're saying, no, A is an endogenous variable.
Yeah.
And if it's A is endogenous, there is no residual. I can do the same in a growth accounting exercise. If I claim that the growth rate of technology is endogenous, then it's a function of the fundamentals. There is no residual. So
I think empirically you would still, and I'm not sure you can hit exactly the observed data point, but I'm not sure about that. Yeah, the residual will be very small in any case. Yeah,
exactly, that's what you're doing. By endogenizing this thing, you're reducing a lot. What in a regression looks like is a residual.
Yeah.
But the point is that everything then is explained by the fundamentals. And here in these exercises, we treat factor endowments as fundamentals.
Yeah. Yeah, no, I guess that's the first point you made previously, right? That then you have this idea of endogenous technological change, which then would take exactly the form that we're. I mean, I guess that's the idea of Daron Acemoglu, and especially in his Power and Progress book, also, right? Of directed technological change, no? Or bias technological change. And you see also here, right? I mean, these are the empirical technology terms. You see, I mean, yeah, it's an index number, so be careful. But you see that there's a lot of very human capital augmenting technologies. They have been developed by the rich countries because they're scarce in human capital, right? So that I guess makes a lot of sense. And you're also right that if I understand you correctly, that indeed factor endowments under the complementarity must explain more, right? I mean, we could have a situation where we have factor bias, but substitution elasticity larger one, then it would go the other way, no? But with the complementarity, it's clear that endowments explain more. It's just nice in a way that we really end up with a counterfactual that is exactly series explained by technology removals, right? So I guess the empirical implication is interesting. So key point, I want to make the case that there's other ways to think about technology and productivity. I've made a suggestion that I take away also from your comments you find interesting, also from a theory perspective, to think about them. empirically, then technology is no source of convergence anymore. It relates quite a bit to also this appropriate, inappropriate technology choice. No, Danny Roderick has made this point recently, that he also says low-income countries won't benefit much from technology transfer or multinationals or GVCs, because all of these rich country technologies, they're essentially labor saving. Whereas if you're a poor country, you want to use your labor, right? I mean, if you look at what Ethiopia is doing or Bangladesh is doing or Vietnam is doing, it's like make most out of your existing labor force. Brings me to policy,
Let me
interpretations.
offer a comment on, because I think that from your perspective is very important, because I worked with CAS technology in theoretical models, and one thing that I've learned and in previous papers is that complementary substitution shows up in the elasticity of the conditional demand for the factor. So if technologies are complementary, the demand for your inputs becomes inelastic. And so, number one, that's something that you can check in the data if you can measure that elasticity. Number two, inelastic demand means that if you have an increase in the abundance of the factor, the price drops a lot and you can get negative income effects. So this is something that when you play with CES technology is very important, or when you move away from the Cobb-Douglas case. Because in macroeconomics, and that's what you're doing, you want to know what is the overall income effect of having these factors. And when you change the relative abundance of the factors. When you go into the complementarity region, you start getting movements in prices and in income in particular that are the opposite of what we expect under the standard notion of elastic demand. The Cobb-Douglas gives you, it's a boundary, but the behavior of prices is as if demand were elastic. So when you move below elasticity substitution equal to 1, you start seeing things that are, again, in particular, if you make capital more abundant, the return to capital falls more than 1 for 1, and so capital income falls. That's a negative effect that shows up somewhere. That's when you do the theory, and I think that these are the things that you guys are picking up.
Yeah, I'm too slow in my mind to follow along. I guess I see where you're heading. Maybe you can drop an email with I don't know if you have some course slides or some paper in mind for that. You're muted, Pietro. You're muted. But anyway, maybe we can take it from there later. I guess the second paper speaks a bit to that, but I think we won't have the time to discuss that. From the policy perspective, I guess one interpretation is to say, well, then we're back to a situation where you need to have physical capital accumulation in this world for convergence. But the other interpretation is, in the end, it's about effective factors, right? So the other interpretation is that poor countries need to develop more technologies that are geared towards the factor endowments of poor countries. So I guess that's the wrap-up part here. This basically, I guess, also goes back to like what Pietro said. I don't know if you have ever seen or can you remember this Matrix movie. So there's this idea you can stay in the matrix, which is not the reality, which tells you here like poor countries are unproductive, right? That's the problem I'm having, coming also from the World Bank, right? You do your growth or development accounting, and then you end up with the insight that poor countries are very unproductive and very inefficient. And that's, of course, right, that's then very nice for these international financial institutions to suggest all sorts of policies to increase efficiency. But I would say it's almost built into the assumption. Here I've showed you a case where the efficiency of all countries is essentially the same. Remember, all countries shift up the same way. So that means all countries are equally efficient at picking their best technology. It's just the case that if you think about it from the long run, rich countries develop rich countries' technologies. I guess that's the idea that Pietro was also referring to. Again, two pictures, right? A typical picture we would see in developing countries, we would say developing countries are poor because labor is sitting around. But if you only have 2 shovels in your village, and that's the only capital, and you have a Leontiev production function, then those people would not be productive doing anything else than sitting around. Yeah? And if they would have the money to come to our countries, right? If you ever wonder, we have so many machines standing around, they would say, hey, why can Italy, Germany, Austria be so rich? They have all these machines standing around. If we would have the machines, we would be so rich. You know? Yeah, I guess that's a nice, hopefully, analog to explain what's maybe going on in the data. I'm gonna stop here. I have a second paper, but I think we already used a lot of time and a lot of very good comments.
Can I ask you a clarification before you go to the second paper? Yeah, so you have all these nice pictures, but I was wondering in the data how the variable capital, how much disaggregated it can be, and the same thing for human capital, how disaggregated can be, because in principle, I mean, with your methodology, you can think of slightly more articulated production function in which you have you put together some type of physical capital, plants with engineers versus. So you have different type of capital is associated with different type of human capital. And that may lead to some more industrial policy prescription or something more. So I was wondering how much limited basically you are by the data in doing that and going that direction.
Yeah, thanks. That's I mean, 2 different problems here is, first of all, the data, right? That you have. I mean, we're already limited. I mean, I think we use the best data we can, but that means the poorest countries we have are China, India, and Indonesia.
But
The
is
types of
there like
capital
a
we can
basic
break down.
distinction? Is there
Sorry?
like a basic distinction between equipment, infrastructures, and like are there like 2, 3 big items that are in which capital is classified across countries, something like that?
Yeah. No, I mean, as the Penn-Wall table people do, or every national accountant does, if you aggregate up the capital stock, you're making implicit assumptions, right? What's the substitution elasticities between different types of capital? The same way as you would do for human capital, which we discussed earlier on.
Exactly, but that's something you would like to control.
Yeah, no, I agree. I agree.
I mean, with your methodology, you like to have a hand on that.
Yeah, I think the Penn-Well table, not on the sector level, which we don't need, but I think on the aggregate level has even types of capitals. And then, of course, where a bit of action is happening is on the intangibles now. How do intangibles come in if you can measure them at all? And then the second problem you have to face a bit, or facing a bit, is like how do you model that in terms of the production structure or the nest, right? You could put together physical and intangible capital, right? This would be one nest. Then you cannot make very interesting comparisons in terms of income distribution with workers, right? Or you assume some other nesting structure where you get more interesting insights for low-skilled versus high-skilled. I guess that's literature that's interesting. The other one, in a way, relates to the second paper. I don't want to go into the second paper, but I want to give you just 2 things because I think they relate to what you were saying, and also what Pietro, I think, in his comment made is like you have then, of course, the aggregation function across sectors, right? And like what we address in the second paper is exactly like we're not looking at human capital, we're not looking at physical allocation of capital across sectors, right? That's what you in a bit referred to. You said is a machine in the building sector, is that the same as a machine in the textile sector, right? That's something we could in principle do. We do it for human capital, for workers. The empirical problem there is that the payments data for capital which we need is a bit sketchy for on the sector level. But yeah, you need this sector aggregator. I think that related to Pietro's comment. And then you also have the problem in this type of exercises. This is basically the contribution of the second paper. If you do those counterfactuals with Cobb-Douglas, you get a closed form solution for the marginal product value of your production factor. And with the CS, it's not the case. And you have these fastly declining returns. I think that's what you referred to, Pietro, right? That
I think that this looks difficult, but in fact is not. I put some references in the chat.
Okay.
I think that my surprise when I started playing with these things is that any micro textbook, in fact, you can do it not just with the CS, with generic production functions. The way, for example, look at equation 16, what's happening is that you have the term after the beta. That is basically a cost share, which is a function of homogeneity degree 1 in the factor prices. And then standard results in micro theory give you the property. Important thing is that everything now runs through those cost shares, which are the analog of market shares when you do.
Yeah, and in the Cobb-Douglas, that's your alpha, no? That's your alpha.
Exactly.
Or your 1 minus alpha, depending on how you set up things.
Here, you're writing the cost share in terms of the quantities. It's much better to write them in terms of the input prices, because the input prices are common across all firms.
Yeah.
And so the cost share, then it tells you how the individual firm or sector responds to a change in input prices. And if you are changing an aggregate endowment, then the channel, everything runs through the prices, because the prices are determined in the aggregate markets for those inputs. And then each sector with the subscript I here responds basically to the price signal. It turns out that it's much simpler than we are used to think about that. There are issues with, as Rio reminds us all the time, that when you move away from the Cobb-Douglas, obtaining it because of the fact that the cost shares or the budget shares are not constant, then if you want to have a balanced group path, you need to add additional structure. But the property that the cost shares, budget share, those objects are homogeneous degree 1 in the price vector gives a lot of degree 0. That gives you a lot of discipline that you can use. So in the chat, I put a link to a paper that I published a long time ago in the JDE, where I use exactly structure like this. And basically, you're looking at the same type of
not enough in the theory part to like follow along, but it's something to think about. So thanks also for putting the references. What's interesting is just very quickly, I don't want to go through the second paper. I guess we're all looking also forward to the weekend. But what is the clue here? No, I guess I can agree on what you're saying. For the type of exercises where we want to find an optimal allocation of labor, it is a problem because there's no closed form solution for the optimum. You cannot write this marginal product value in terms of age. That's the problem. So there's no analytical solution for this type of exercises. You have to solve it numerically with an algorithm.
Optimal here means social optimal or profit maximizing?
Output maximizing of the economy. So it's various sectors that have a Cobb-Douglas aggregator. And within each sector, you have a CS.
I don't see why you need the closed form.
So the planner's problem is you maximize output over sectors I. The standard is a Cobb-Douglas across sectors.
Right, but that means that if you take a log, and then you're going to see the log aggregate output is the weighted sum of log sectoral output, and you know
yeah, exactly. You have this
so
sector pairs. The sector pairs,
and I'm not sure that you need a closed form solution for the decisions, because you can characterize them, and then when you go to the data, you can take an approximation or something. I mean, when you look at the shape of these solutions, even with generic production functions, one can play with that. So
Well, let me know. So far, it's the first time anyone says there could be an analytical solution. We're saying at least there's a numerical solution. That's basically
sure, absolutely, yeah.
yeah. Numerically, there's a solution, but no closed form, yeah, theory solution. All right. Other comments, questions? I'm trying to find the chat. Oh, here it is. Yeah.
So may I make a remark
Sure.
with respect to the central piece of the paper? So if you go back to Cassell and Coleman, for instance, the main message there was that you may have barriers to adoption, or you may have inappropriateness of technology. And so either one of these would explain the fact that countries would have lower level of per capita income than the countries at the frontier, right? And so either by removing barriers or to adoption or allowing the countries to pick the appropriate technology given factor endowment, then you would allow countries to move towards the frontier, whereas the countries at the frontier were already picking the optimal technology. So the thing here is that you find that even the countries that you would think would be at the frontier are not really there, because in your experiment you see that everyone will be moving towards the right, by adopting even more appropriate technology or by removing further any remaining barriers to adoption they may have, even if they are already developed countries. That's why you get this sort of neutrality result, right?
By right, you mean in the income distribution? Yeah, exactly. Yeah, I think I can
Yes.
follow. Yeah.
Yes, in the income distribution, given the support you were using.
Yeah, yeah.
And I think that's really new. So usually people just think that if the US is at the frontier, then that's the best they can do.
Yeah.
They're already doing it. But here you're saying that no, even these guys are able to do even better. And so by allowing everyone to remove those barriers to adoption or just pick the really appropriate technology, then even the very developed countries will improve further their level of output per worker and output per capita. So I think it's the main message, right? Because the rest we already knew, right?
Yeah, I mean,
barriers to adoption, inappropriateness, etc. But we were not really aware empirically that, okay, you do have this sort of leeway even for developed countries in order to improve further your performance.
I like
I don't
that.
know if you agree with me.
I like it. I like it. It's a very good point. I wonder whether in your world, with this notion of appropriateness, we even have a technological frontier.
Exactly. Exactly.
I think that's what Pedro just told us.
Yeah. No, a couple of remarks. Even that point, that last point, I have to confess is not new, because that's the argument that Francesco Caselli has made in his 2005 paper or handbook chapter, and especially in his 2016 book, although not very forcefully. What is new is that we can pin down empirically the substitution elasticity and can say this is the most plausible numerical value with really this zero result that everyone benefits alike. And therefore, with the additional result that stretching it that far to say poor and rich countries are as efficient in picking their optimal technology. They're all given their factor endowments and the available menu of technologies, they're all doing the best they can do. I think that quantity that's new because we can pin it down. The other point was, sorry, I also found interesting. Yeah, is there a production technology? Yeah, I mean that's what I tried to say is like yeah, we can in theory we can say these are the points we observe. Let's draw a production technology frontier, but then nobody tells us that the optimal technology will be on that frontier. So in a sense, we could say these are the limits, these are the frontiers, right? We could say let's draw whatever like the outmost line in this space. But then we should say the optimal technology is can be every point in the plane we're creating. You know? It's the optimal point does not, I'm not sure it has to be on that frontier. I don't think it has to be on the frontier. No, it doesn't have to be.
I think the implicit concept of technology frontier that people that comes from the old-fashioned development accounting is that there is no such a thing as an optimal technology that is a function of country-specific parameters, factor endowments, factor-specific fundamentals. The moment that the optimal technology is a function of country-specific fundamentals, I'm not even sure that there is a concept of a technological frontier. Definitely not the old-fashioned technology. Because the old-fashioned concept says that if I take the best tech practice and I give it to a poor country, then I obtain exactly what you showed. It doesn't happen. And now I'm wondering whether this concept of technological frontier has any bite when we think seriously about appropriate technology means that the auto-maximizing technology depends on country-specific fundamentals. I no longer see a concept of technology frontier there.
I mean, formally you can define a frontier in my view, right? But I don't think it makes a lot of sense. And empirically, I would say, well, there's just a discrete limited set of putting together capital and labor. It's not like you can arbitrarily shift around in this space. I guess that relates a bit to this concept of discrete versus smooth changes in technology. Yeah. But no, I mean, in this plane, you can write down the frontier and say every optimal frontier must be on, or technology must be on that frontier. Does it make sense? I have serious doubts about it. Yeah. All right.
Okay, Konstantin. I think we are done.
Yeah. No, let me say thanks for all the comments. It's I really enjoyed this seminar, like having all the theory inputs and also the section you organized in Rome. Please follow up. I'm very interested also in like the questions you raise, right? I mean, I'm not the theory person to develop them, but I'm like super happy to think along and connect the dots. I have an ongoing small scale project with Maria Sam, who you may know, who's also worked with this type of production structures where we especially try to integrate intangibles, emissions, robot capital, etc., into the production structure. So there will be a couple of things one could do. So please reach out. Yeah.
Okay, so I will stop the record.